I'm Christine, and this is the alternative solution video to the extra credit for test 3. This is the question. So George already put up a video, and what he did was he used the law of sines and the law of cosines, and first found the length AC using the law of sines and using the lengths and the angles of triangle ABC. Then after he found the length AD, which is what we're supposed to find, and using the lengths and the angles for triangle ACD. So you could also do this by finding the length BD and then using triangle BD, ABD. So I'm gonna first show how to do that method. And so you draw the segment BD, and using the law of cosines, you can set this equation. So BD squared equals 6 squared plus 10 squared minus 2 times 6 times 10 times cosine of 130 degrees. So then BD squared is equal to 213.1345, and then BD will then equal 14.599. So this equals 14.599, and then using this, we could make another triangle, BA, and then BD, then AD. So using this triangle, we're going to use the law of sines first to find the angle ABD, and we know that this part is 110 degrees, but we don't know the length of the measure of this angle. So we're going to first find that using the law of sines. So we're going to start with what sine of 130 degrees, which is opposite to 14.599, is equal to this, which is we'll say is theta. So that is equal to sine of theta over 6. So if we isolate sine of theta, we get 0.3148. Then we take the arc sine of both sides, and then if we do so, we get theta is equal to 0.314. Theta is equal to 18.306. So that means the length of this whole entire angle is equal to 128.35 degrees, approximately. So then after that, we use the law of sines again, using the green triangle. And if we do that, then AD squared is equal to 5 squared plus 14.59 squared minus 2 times 5 times 14.59 times cosine of 128.35 degrees. Then that AD squared is equal to 328.3937. So then AD is equal to 18.12. So that's one way to do it. And then what I did on the exam was I found it's a bit more complicated. So what I did was I found the angle between I found this angle, which we will call theta, and then after that I found the lengths B, and we'll label this O. So then I found the lengths B. I found the lengths B, BO, and then OC, and then adding that is equal to 10. Then I found the lengths of AO and then DO separately, and then just added those up. So I'm going to show that method right here. So this is theta, right? And then so this angle would be 50 minus theta, because 180 minus 130 minus theta is equal to 50 minus theta. And then this length would be 70 minus theta, because 180 minus 110 minus theta is equal to 70 minus theta. So knowing that, we could find the lengths AO and AOD using the law of sines. So first we'll find AO. So AO, we first have to make a ratio with BO. So that will go like this: BO over sine of 70 minus theta is equal to 5 over sine theta. And then if we isolate BO, we get 5 times sine of 70 minus theta over sine of theta. And then we found BO, which is this value. We're going to evaluate this later, and then we have to find OC. So OC is equal to, using the law of sines, OC over sine of 50 minus theta is equal to 6 over sine theta. And then we isolate OC, which is 6 times sine of 50 minus theta over sine of theta. And then we know that BO plus OC is equal to 10. So if we add BO and OC, it would equal 10 is equal to 6 times sine of 50 minus theta over sine of theta plus 5 times sine of 70 minus theta over sine of theta. So we add those up, then so it would be 10 equals to 6 times sine of 50 cosine theta minus sine theta cosine 50. This is basically just the difference formula for sum for sine angles, and then this is plus 5 times sine of 70 cosine theta minus sine theta cosine 70, which is all over sine of theta. We're going to place sine on the other side, so it will be 10 sine theta is equal to 6 times sine of 50 is 4.59, and then 6 times cosine of 50 is negative 3.85, adding this, multiplying the negative. Then 5 times sine of 70 is 4.7, and then negative 1 times cosine of 70 times 5, and so this part is negative 2.05. So this would mean this is 4.59 cosine theta minus 3.85 sine theta, and then plus 4.7 cosine theta, and then negative 2.05 sine theta minus negative 2.05 sine theta. So then if we bring sine onto this side of the equation, then it's 10 plus 3.85 plus 2.05 times sine theta, which is equal to 4.59 plus 4.7 cosine theta. So this is 15.9 sine theta, which is equal to 9.29 cosine theta. So if we bring sine and cosine onto one side, then we see that this is equal to tangent theta, and then the numbers on the other side, so 9.29 over 15.9. So tangent theta is equal to 9.29 over 15.9. So we take the arctan, so if we do that, then we find that theta is 30.3 degrees. So so what we found so far is that this length is 30.3 degrees, and so is this. And then using that, we could use the law of sines to find AO and DO. So we can first start with DO. So sine of 130 degrees over DO is equal to sine of 30.3 degrees over 6. So we isolate DO and we get that DO is 9.11. And then AO, we start with sine of 110 degrees, 110 degrees over AO, which is equal to sine of 30.3 degrees over 5. Then we isolate AO and find the value, so it's 9.3. And then AD AD is equal to AO plus DO, which is 9.11 plus 9.3, which is equal to 18.4. The rounding is a bit off, but it's close to our previous answer, which is 18.12. So this is one way, and then there's also another way, which is breaking up the triangle into breaking up the vertex and finding the x value and the y value for each vertex. And if we do that, it's something like this. So we start by breaking up the triangles. So for this vertex, this triangle would look like this. This vertex, there's no triangle, so we can just leave it at that. And then this triangle, this vertex, the triangle looks like this. So we'll label this vertex 1, vertex 2, and vertex 3. So let's start off with vertex 1. So we have a triangle like this. It's a right triangle. Yes, right triangle. This length is 6. DC, and then let's label this about x. This point x, and then this is a linear line, so this whole angle would be 180 degrees, and then this angle would be 180 minus 30, so that would be 50 degrees. So this is 50. We know that this is 90, so we do 180 minus 90 minus 50, and that is 40 degrees. This is 40 degrees. So we could use the law of sines to find the each. Oh wait, this is 40. I labeled this wrong. DC is 6. So using that, we could find dx and cx. Dx would be our y component, and cx would be our x component. So using the law of sines, we're going to do this. So stuff is 6 over sine over 90 degrees. Sine 90 degrees. That's equal to dx, which is our y component, and that's sine of 50 degrees. And that would mean dx is equal to 4.596 after you isolate the values. And then we find our x component, which is which we start with 6 over sine of 90 degrees, which is equal to cx over sine of 40 degrees. Then if we isolate cx, we get 3.856. So we found our first x and y components for our first vertex. So we're just going to label it here. Vertex 1, the x component is 3.856, and then our y component is 4.596. Vertex 2, it's very straightforward. It's just one straight line, so that means our x component is 10, and then our y component is just 0. For vertex 3, we have to use the law of sines again. So so we start with 5 over sine of 90 degrees is equal to YB over sine of 20 degrees. Sine, I'll just bring this diagram down here, just so we could refer to it while finding the sides. So we isolate YB, and then we get that YB is equal to 1.71. And then we do the same for YA, so 5 over sine of 90 degrees is equal to YA over sine of 70 degrees. And we isolate YA, and that's equal to 4.69. So for vertex 3, our x component is 1.71, and our y component is 4.69. So okay, going to bring this diagram down over here. So far we found that this length is that length So we found that this length is 1.71, this length is 4.69, and then we're going to bring this down, so this length is 10, and then this length, we're going to bring it down again, and this length is, this length is 3.856. So our x total would be 15.566, and then we start over here, so 4.69, and then this length is 4.596. So if we just extend it over here, then 4.596 and 4.596. So our y total would be 9.288. So using y total and x total, we could make another triangle. This is 5.566, and our y is 9.288, and this is AD. So if we use the Pythagorean theorem, we get that 0.288 squared plus 15.566 squared is equal to AD squared. So AD, if we evaluate this value, then it's 18.1254. Yes. Those are the three methods that I know.